Welcome to the biggest tunneling project on America's East Coast, the HRBT expansion. We're going to show you everything about the nearly $4 billion HRBT expansion project, including the incredible active tunneling operation.
But before we do, why the heck do they need a tunnel here in the first place? The U.S. Navy set up shop in the area during World War I and aggressively expanded during World War II. Today, Naval Station Norfolk is home to America's Atlantic Fleet and is the world's largest Navy base. As the area grew, more people needed to cross the water between Norfolk and Newport News. In the early 1950s, the Virginia Department of Transportation, or VDOT, started a ferry system to move a few thousand cars daily. With this quickly overwhelmed, they started looking for a more permanent solution. The obvious answer was a bridge. However, because of the naval station's location to the west, planners quickly ruled it out due to the potential national security risk. If, for whatever reason, the bridge collapsed or suffered damage, it could trap the entire Atlantic fleet. A tunnel under the channel was the next best option, with the first tunnel completed in 1957 with 2 lanes, one in either direction. After briefly renovating the first tunnel, the 2 tunnels still operate today, designed for about 60,000 vehicles daily. However, with traffic exceeding 100,000 vehicles daily in summer months, VDOT needed to modernize and expand the I-64 corridor yet again, with the HRBT expansion project being their answer. The $3.9 billion project will ultimately expand 10 miles of interstate from the existing 4 to 8 lanes. While the tunnels are the big-ticket item, most of the project is technically above land, with new trestle bridges to the north and south of the tunnels and widening to the lanes on land into Norfolk. Once completed, westbound traffic will use the 2 existing tunnels, and eastbound traffic will travel through the 2 new tunnels. As mentioned, the tunnels only go under the main navigation channel, about 1.5 miles each. They connect 2 artificial islands, with the North Island requiring expansion by about 15 acres to accommodate the new tunnels. But today, thanks to the amazing access from Hampton Roads Connector Partners, we start our visit on the South Island, where the tunneling journey originally began. We started our day at the Slurry plant, where the excavated material from the TBM is processed.
That is why you have to build a tunnel, not a bridge. This is the Slurry plant. For the TBM, if the TBM was a body, the whole system, this is the heart. This is what is taking the liquid, the material from the front of that TBM all the way through the TBM, out the tunnel, to here to remove the sand, the shells, the mud, the clay from that bentonite water mixture. And then once it's clean, it circulates that bentonite water back to the TBM, on and on it goes like a closed loop, just like my heart, if I had one.
So this is a conveyor. So all of the really giant pieces that get circulated, all the big stuff, comes directly from above. And that is the trommel. You'll see that when we go upstairs. And it all falls into here, and everything. If you see these machines that are right above us that are shaking a lot,
Yeah.
It's basically like a sieve.
Yeah.
Do you know what a sieve is?
Yeah.
So that's literally all it's doing. It's shaking out all of the fine material, all of the stuff that we're not allowed to have back to the TBM, and it goes onto the conveyor belt. So the reason for the STP plant is because you need to have a certain density for your material when it's feeding the TBM. And then when it comes back, it's going to have a higher density because it's all the material that we're removing from in front of us, you know? So when it's coming back here, they need to treat it, remove all of the sand or whatever type of geology that we're mining through. So here it's mostly, it's coarse sand, super fine material. Our sand is really fine.
That is the finished product from the slurry plant. That is the bentonite water mixture that will be sent back to the TBM, working away, and will eventually be injected at that cutting head there. Look at that. Wow. So that's what we're after here. That's what this plant is cleaning. It's taking the mixture that comes out, takes the mud and rock and sand out, and cleans the bentonite water mixture, puts it back in.
After visiting the slurry plant, we headed over to the south portal where the TBM started and where Flatiron stores the hundreds of tunnel segments needed for this massive project.
Yeah, the pit of nothing but...
Each ring that the TBM is putting together is 9 of those segments. Each one of those segments is 10 tons, 20,000 pounds. They're loading that transport vehicle there with 9 of them for one ring, and that will go all the way through that tunnel, go to the other side, and then come back in the TBM to load it up for that next ring. Also, these 2 pipelines are what connect the slurry plant to the TBM. Everything has to go into this tunnel here. This is where the TBM began. So on the left, we have that clean slurry in that we've cleaned through that plant. And on the right, we have the dirty slurry with all of the material that's being cut out of the tunnel, being removed through that plant, recirculating all day long.
We're starting shoring for the roof slab in cell 3.
A dumb question.
No, there's no dumb question.
Well, there definitely are. I have plenty of them. Why 3 circles? Why not a big rectangle?
That one I can't answer. I've only been here a year.
Okay.
I wish I could, but
Do you know why 3 circles
To
instead?
be able to fit the TBM and the way the circles are, they said that it would be better for the type of soils. From what conversations that I've heard.
Okay.
The type of soils that
So
we
this is
had in here,
based on
because
engineering?
we needed to do jet grout, and then we also needed to do soil mixing in the very front when we were walking underneath the STP.
Okay.
So this is what.
Okay. So we're in cell 2. That's 1, 2, 3. This is where they launched the TBM. That's where it all began right there. Over on the left side is where it'll eventually break through next year, it sounds like. This year. And right now they're building these walls now that the TBM is well out of here. This will be the approach, so traffic will be going that way. This will all be covered by these enormous concrete structures here. All of this will be covered from top, so you can walk around up here, and then traffic will be coming out, headed that way on the other side.
But before we head into the tunnel, we had to check in and get our tags. These allow Flatiron to keep track of who is going in and out of the tunnel to ensure no one gets left behind or lost.
Going in.
Bravo 6. Going dark.
Watch your step.
Oh,
But
wow.
you can see in here, this is inside of the L wall. So what they have to do is that slab that I was telling you about that they need to continue to pour is right above you.
Okay. And is this just emergency access for
Correct.
utility? Okay.
Correct.
Something to note is the TBM makes a circle, but you really need a square. So all of this concrete formwork that's being performed now makes it into the tunnel that people will be driving through, but there's still volume outside of that for access, for maintenance, for utilities, for emergencies, etc. That's what this corridor is, that most people driving through the tunnel will never see. Concrete truck, but tunneling version. Got tiny. Really nice cross section here so you can see the walls that they're pouring versus the circular shape of the rings that the TBM have created. So that's the wall. This will be the barrier that traffic will see. Traffic will be right where I am. Up here is where this concrete truck, tram, whatever it's called, ended up. It's pouring the concrete into the formwork that's making up those walls on the side of the tunnel. It's self-vibrating, so the formwork itself can consolidate that concrete around that reinforcing steel and make those walls, and it'll just continue to slide all the way down the tunnel.
Thank you guys for coming today.
Huh?
Thank you guys for coming.
Oh yeah, thanks for having us. This is great.
All right, I promise we are almost at the TBM. To give you all some context, we started at the south portal and walked all the way to the north, which is about 1.5 miles, or longer than Jack and Wyatt had walked in months. So we had to stop for many water breaks along the way. And before seeing the TBM, there's one more stop to make.
This is the low point in the finished tunnel. Eventually, what they're doing here is they're building this structure to have a permanent pump station to remove water from the tunnel non-stop. You've got water coming in here from both sides as this is the low point. So the tunnel goes like this. We're at the very bottom of the U. So this will non-stop be pumping water back out so the tunnel doesn't flood. All right, we made it all the way through the tunnel, a really nice walk under the water there. This is where the TBM burst through for the first time. Mary, we can cut to that footage.
They should have took that man lift from over here. We don't know how much water is actually going to come through here.
Everybody's cheering, it's chewing through the concrete. That happened right where I am standing. And then this is the final ring in this tunnel here, ring 1191, so almost 1,200 concrete rings from one end to the other. This is the very first tunnel she dug. And then over here is where they then disassembled.
All right. Enough waiting. We'll come back to how they turned the TBM later. Let's skip ahead and get to the machine.
Thinking of the best route. We will come down and then we will
very
hit
back.
We will start here.
This one,
This is gantry 4.
this one's way more spacious than the Australia one. Way more spacious. So this is gantry,
Don't say that too soon, eh?
well, I don't know.
Before stepping into the TBM, it's a little hard to see what's going on from the inside, so let's review how these amazing machines work and some of the specs behind this specific machine.
As is tradition with many large TBMs, The project team held a naming contest in 2020 with local students. The winner suggested Mary, after Mary Jackson, a prominent engineer and mathematician. The machine was built by the German company Heron Connect, also known as HK, and Hampton Roads Connector Partners picked it up at the factory in the summer of 2021. By the end of 2021, Mary had landed in Virginia, ready for assembly. And now for some fun stats. The cost was $70 million. Height is 46 feet. Length, 430 feet. And finally, the weight is 4,700 tons. Crews began assembling Mary on the South Island in 2022, and the complete assembly took 6 months. After decades of planning and years of work, she began her journey north in April 2023, making her way through the tricky Yorktown layer. Now for how she tunnels. Think of these machines as giant mechanical earthworms.
Starting in the front, we have the enormous cutter head, which rotates through the earth, cutting and removing it using special bits designed for this project's material.
As this machine works in soft earth, the front of the machine is also under immense pressure, which helps push back against the earth during tunneling, preventing collapse or sinkholes. Behind the cutting head is the shield, the heaviest and only component of the TBM that directly contacts the earth. Here lies everything needed to spin the cutting head, remove the spoils, and build the concrete rings. Remember the ring segments we saw earlier? This is where the machine installs them. Using an enormous vacuum placement arm, the crews can grab each of the 9 ring segments and place them in the corresponding location, eventually forming a complete concrete ring, which serves as the structural support for the tunnel while crews build the finished roadway.
We didn't see ring construction happening during our visit, but we have great footage from another tunneling project to illustrate.
How does the machine propel itself forward? Well, enormous hydraulic jacks, seen here, push against the newest concrete ring, applying pressure at the cutting head while seating the ring into the previous rings, forming a tight seal. Pretty slick. The rest of the TBM, which covers most of its length, houses the command center where one operator runs and positions the machine. It also includes transformers for power, conveyors to remove the spoils, and a seemingly endless volume of piping to run the monster machine as needed. At the back of this little city lies where crews can extend the various utility lines for the machine and where the next tunnel segments enter. A crew of about 20 runs the machine 24 hours a day, while crews on the surface support it. And with the background, let's check out the TBM up close.
So this is a material cart. So the material cart takes the grease, takes the cutter head pieces whenever we're doing changes. This takes anything you can imagine from the back of gantry 3. So right now we're in gantry 3, and it takes you all the way to the front.
Because everything's heavy,
Yes.
since this is a big machine. So they'll bring it in here,
Yes.
they'll
Everything
lift
is
it, place it,
ginormous.
and then shuttle it all the way.
Exactly.
Wow.
You need a chain hoist to lift almost everything.
Yeah. See, that's something you don't think about.
It's taken seriously.
That's awesome.
And we put our steel piping. This is where we do our extension for the steel piping. And that happens here. It's a very difficult job because you
Okay.
need to do it by hand. You have 3 or 4 guys picking up these pipes, which is schedule 60, picking it up and then putting it on the brackets.
So this is all, these are all the utilities.
This is
It's-
all from TBM.
It's water,
You have water,
oil,
air.
air.
So you have water in, water out,
Yeah.
and air, and then you have a spare line, which is for air,
Okay.
because it's for the Samson. And then you have your A component and you have B component, your accelerator. So you have your accelerator, which is normally your normal grout that you mix, and then your accelerator gets mixed in at the last second when we are grouting with the machine.
So these are the machine's arteries, essentially. And as the machine goes that way, the crew up here then attaches, takes the machine's arteries off, allows them to go that way, go back into the hose reels, essentially. And then they extend these more permanent steel pipes on the side of the tunnel wall that we saw while coming in and in the other tunnel. Like, this is way bigger. This is a big machine. It goes all the way down there. Like, I don't know, it looks like a football field almost. I'm not a football guy, but it's pretty far.
The transformers, so the different transformers, so this side of the machine is our miscellaneous transformers that give energy or give power to everything else in the machine. And the 2 over here to the left are for the cutter head.
Wow.
It's crazy.
Crazy.
So you can see our tools. So we have different types of tools. So we have knives, we have rippers, and we also have disc. So you can see the new from the old.
So these are at the front of the cutting head.
Exactly. You can tell this is a new one
Wow.
because it's not completely shaved down.
So they're, oh, so this is a used one.
This is still newer.
Oh, it's still newer.
Yeah,
Wow.
correct. And then you have all of the tools that you need to use to be able to change the parts of the cutter head. So a lot of it is hydraulic.
Crazy. Yeah.
So whenever you do a tool change, you need to connect those to the different slider pipes. And what you do is that once it's connected, you use a cylinder to retract it or to push it. And when you open the guillotine gates inside of the machine, because we have an atmospheric cutter head, an atmospheric cutter head allows you to change tools whenever you want, as long as you're not excavating.
So
But
you pull it out from behind the cutter
you use a
head.
hydraulic block.
Yeah.
But you need to open the guillotine gates. Once you open the guillotine gates, because you need to flush everything, clean everything first, open it. Once you open it, then you can remove the old tool.
And then slide the new one in.
Then once you remove the old tool, you need to be able to slide one of those and put the new one in.
Yeah.
So what happens normally is that they remove the old tool, close the gates, bring it up, detach it from the slider pipe, put in the new tool, take the new tool down, and then slide the new one in.
Oh, nice.
This is Jose. He is from Spain
Hello.
also. And also, I'm American, but he's from Spain. He came here also as an expat to do the pilot of the machine. He's very good. He is the best. Okay, so I'm going to speak really fast. So these are all the controls of the machine. So you have the controls of the thrust cylinders here, and it shows the different groups. So you have A through I, because remember I told you the 3 thrust cylinder pairs per one segment. So they split them up. The 27 divided by 9 is 3 per 1. And then you have the different cameras and things like this to know what is happening in the machine, so you can see if something is going wrong. And you also have normally the PLC in here. Antonio is on the I was going to say Carritos 4, but he's on gantry 4. So this is the schematic of the machine with the different valves. So he's able to push and manually open or manually close whatever he needs to do depending on the type of flow that we need. So we are 3,000 cubic meters per hour normally. Wow. And then you have the different, so whenever you have any sensors or any pumps that have a flow meter on them, the important ones at least for any of the feed pumps for the slurry, P0, it means feed pump within the machine. P1 means feed pump to the machine. P2 means return line to the STP, or feed to the STP. So depending on the number,
So a little more complicated than like a steering wheel.
basically. Think of a Formula One steering wheel.
Yeah.
And then you have the level up in here, and he's able to use the VSU from, or the monitor control that HK installs into here. And he can see the ring building that's happening in here also.
Yeah.
And then you have the guidance system over here.
And so that's how you know where you're going.
That is the guidance system that he does with our surveyor.
After our rundown of how the machine was operated, that I 100% comprehended, we made our way to the final stop of the tour at the front of the TBM where the segments are placed.
This will be the next ring. We've got 9 segments ready for that arm to place once the machine starts moving again. So they've brought these in. They've lifted them with that crane 3 at a time. They've put them on the tram. They've brought it all the way through that first tunnel. They've turned around. They've come back through, down, all the way through the machine. Now they're at the very front of the machine. They're always lined up 1 through 9. So we have S1 here, and there'll be S9 at the very back. And then the computer, the positioning system, will tell the operators where to put each one of these segments to determine then how the machine moves forward, because by positioning these segments differently, they're able to steer the machine. The cutting head is pretty close to where Jack is standing, the camera, where you are. Most of the machine is behind me. So someone asked, isn't it scary to be underground? And it's not at all, because you never see the ground. Most of the machine, almost everything within this tunnel, is already within these concrete rings that the machine, the TBM, is assembling as it moves. So at the very front of the machine, we have that shield pressing against the earth while the concrete rings aren't there. And then almost right after that, we're building those concrete rings. So majority of the machine never sees the earth. So these cylinders here, there's 27 pairs of these cylinders. They're pushing on this ring right above us here. This is the last ring that they've installed today, this morning. And these cylinders, 27 pairs, are then pressing against this ring into all of the other rings that have been set by the TBM. And they're pressing all the way around the circle evenly to then propel the machine, that cutter head, into the earth in front of us, which then drives the machine forward, allowing the tunneling to take place. So those cylinders are what propel this entire machine. And then once they've pushed the machine far enough ahead, they'll retract those cylinders, they'll place the next ring, and then they'll push those cylinders up against the next ring, rinse and repeat hundreds of times, almost over 1,000 times, and they'll be at the other end.
Now that our tour of the TBM is over, let's head back outside and check out where and how they turned this 4,000 plus ton machine around to start the second tunnel.
This is where the TBM Mary broke through. The problem with a TBM is you can't do a 3-point turn with it all that easily. So as it broke through, they allowed it to build those final rings, have that shield come out of the tunnel. Once the shield was out of the tunnel, they were able to disconnect it from the rest of the machine, the gantries behind the shield, which allow the machine to do what it does. The shield, the cutter head on the front of it, all was then leveled out here, put onto a nitrogen table, which is kind of like an air hockey table. So it was levitating just slightly and then was spun around where we are right now so that it was then facing the other direction 180 degrees completely all the way around. At that point then, they needed to get the gantries out because the tunneling can't start without the rest of the machine. So this is where, from about where I'm standing, they then pulled them out of the tunnel one by one because at that point, there's nothing to propel the machine. Then they pulled them out, they spun them around, they put them back down here, and with a mobile transporter, then slid them over there and started to reattach the machine, rebuild the entire machine, ready to head in the other direction. And that entire process was 6 months. A huge thank you to Hampton Roads Connector Partners, VDOT, HRTAC, Dragados, Vinci, and last but not least, Flatiron. They were the ones that really got us out here, for having us. I hope you enjoyed your tunnel tour as much as we did. We'll see you on the next one. Stay dirty, everybody.